for us to look at. We'll start with that long division like you asked for. All right, so x cubed minus 2x squared minus 11x plus 12 divided by x minus 1. You start with what do you multiply x by, this one, the leading one here, to get x cubed? What do you multiply x by to get x cubed? That's the question.
X squared.
X squared, and that goes above the x squared. So you think of it as the x squared column. Then you take x squared and multiply by x and -1. X cubed minus x squared. And then we talked about this idea of changing the signs. So it becomes negative followed by a plus.
Okay, forgot about changing the signs.
Yeah. Normally you subtract when you're doing a long division. Changing the signs converts subtraction to addition. You should always get 0 in the first position here. That's kind of standard. And then you got minus 2x squared plus x squared minus x squared here. And then you bring 1 down. You could bring more than 1 down, but you for sure have to bring 1 down. Is that okay?
Wait, so how do you get the negative x squared?
You're adding minus 2x squared plus x squared.
How does that get negative x squared?
You've got -2 of them and +1 of them. So you owe someone $2, you hand them $1, you still owe them $1. This is what you're doing right here on the right, minus 2x squared plus 1x squared.
The negative 11x.
Just bringing that down.
Oh, it's the next step.
You restart. You say, what do you multiply x by to get this leading one? Minus x squared. So try not to overthink it. How do you get x squared from x? Just do one piece at a time.
Would it just be x?
Yes, x times x gets you the x squared. To get the negative, that means it's negative x. Negative times positive x gives you the negative x here. Is that okay or not? All right, so we're going to take this negative x and multiply by x and then times -1. Negative x times x is negative x squared. Negative x times -1 is positive x, like that. And then guess what you do again? Change the signs. The first one should be 0 if you've done it correctly. If it's not, maybe you made a mistake, maybe you forgot to change the signs. Could be a couple possibilities. This next one here is minus 11x plus -x, or -1x, if you will. That becomes negative 12x. And then you bring the 12 down.
And then it's what times x gets to 12x?
Negative 12. Yes. What do you say?
Would it be -12?
Yes. Very good. So then you multiply, sorry, I lost the screen there. -12 times x is minus 12x. -12 times -1 is positive 12. And yet again, you change the signs. Plus, negative, add them together. Oops, I meant to go back to the other color here. And you can see they're both 0. You really want 0 right here at the end. That's your remainder.
So the full answer would be x squared minus x minus 12?
Yes. So let me just kind of just grab a few of these things just to kind of show you the like full circle here. So here's what we were doing. We took x cubed minus 2x squared minus 11x plus 12 and divided it by x minus 1. It equals x squared minus x minus x minus 12. This is what we're saying. Like this is our original problem, and it becomes this. All right. Now another way to write the thing on the left here is with a fraction bar. Oops. If this is too much, we can just go right to some new problems. But if you write it with a fraction bar, if you multiply both sides by this x minus 1 on the bottom, so imagine multiplying by x minus 1, the x minus 1's cancel. And so your answer times what you divided by equals the original, which is kind of neat. It's kind of the whole, going full circle, how you get back to the original. Okay. Now, most students, they do long division and they think it's the worst thing. It is useful. There are some problems where you can only do long division, but then you learn synthetic division and you're like, why did I ever do long division? Basically, it's like, when you first learn to drive, you're like, wow, I can't believe I used to walk or ride my bike anywhere. You get there so much faster. So here's how synthetic division works. It's a little bit different, but we're going to use the same problem here to kind of work through this. So let's say we want to take x cubed minus 2x squared minus 11x plus 12 equals 0. I'm sorry. And we want to divide this by x minus 1, just like we were doing in the previous problem here. So the first thing you do is you set the x minus 1 or whatever's on the bottom equal to 0. And then you solve for x. So in this case, x equals 1. Is that okay? Clear?
No, I don't know.
Just follow along here. So we're gonna like, we're doing the same problem, but we're gonna do it a different way. But the start of it is you have to set this thing equal to 0, and basically it's the number that makes this 1 on the bottom. Or x minus 1 becomes 0, so x is 1. All right. So this 1 that we just calculated goes in this box here on the left. And then the next thing I do is I'm going to write the coefficient of x cubed, 1, the coefficient of x squared, the coefficient of x, and the constant next to this 1 in the box here. So again, that first line is 1x cubed minus 2x squared minus 11x plus 12, but all I'm doing is writing the coefficients. This is the setup. This is the setup for synthetic division. So next you bring the 1 down. Always bring the 1 down. You take this 1 on the bottom and multiply it by this 1 here. That's positive 1. You put the result here. Then you take -2 and add 1. That's -1. Then you take this -1 here and multiply it by 1 to get -1. You add -11 plus -1. That's -12. -12 times 1 is -12. And you add to get 0. This is synthetic division. Synthetic division is doing the same thing we just did. Notice our answer here is going to be 1x squared minus x minus 12, which is exactly the same with what we had up here, but we didn't have to do the long division.
I don't get this one.
So the question I would have for you is like, what would be the purpose in us learning synthetic division? Because you're not going to be asked a question, I think, explicitly that says like, thou shall use synthetic division to solve this. Should we keep going on this, or do you think there's maybe a better topic to move to?
I don't know. Is this one faster? I just don't know how to do it.
It's a lot faster, but I mean, I'll show you many examples here until it makes sense, but let's just try that. Okay. So let me give you another polynomial here. Let's say it's x cubed plus x squared minus 4x minus 4. And we want to divide this by x plus 2. Okay. So you take this thing on the bottom, x plus 2, and you set it equal to 0. Subtract 2 from both sides, x equals minus 2. You put that minus 2 in this box over here on the left. Then up here at the top here, you write the coefficients. So it's 1x cubed, 1x squared, minus 4x minus 4. But you just write the coefficients, not the variables.
So do I always change the x to what the second number is?
When you say second number, do you mean
On the
the one in
bottom?
do you mean the one in the box, or the one? This one is for the one, that one there, and then that's for that one.
No, the x plus 2, you change the 2 to a 0, but do you always, then you got to figure out what the x is, but do you always just change the x to whatever that number is? Because before you change it to a 1 and now it's a 2.
Yeah, so in the previous problem is x minus 1. So when we set it equal to 0, it's solve for x, you get 1. 1 minus 1 makes it 0. -2 plus 2 is 0. So -2 is the number that makes the bottom 0. So it's like the answer is it's whatever makes the bottom 0. That's what goes in the box. Like let's say it was x plus 3, it would be minus 3 here.
Okay.
X plus 4, it would be minus 4 here.
So it's always just the opposite symbol
Yes.
number.
Yes. Yes. All right, so start by bringing the 1 down. And then you take whatever number's down here, and you always multiply it by what's in the box and put in the result in the next position. Like that. 1 times -2 is -2. 1 minus 2 is -1. So you always add vertically. The reason you bring this one down is you really think of it as a 0 here. If that helps, we can write a 0 here because you're always adding. But the number that goes here comes from taking the 1, multiplying it by the -2, putting the result here, and then you add vertically. -1 times -2 is 2. Add vertically, that's -2. -2 times -2 is 4. And that's 0.
Then afterwards, what do you do to it to finish it?
So good question, because there is more to do here. This is x cubed to start. When you divide, you reduce it. So now this is x squared, this first one. You write it as 1x squared minus 1x minus 2. And then because this is a quadratic, you can use any one of the various methods that we've talked about to solve it. You can factor, typically you'll factor. You could use quadratic formula. I don't remember if we did that or not, or you can keep going with synthetic division. Like you can do synthetic division again.
So that's not the final answer?
No.
Oh. Well, what's quadratic formula mean?
We haven't done that because I didn't know if it's kind of like a more advanced thing that didn't seem relevant for solving all the quadratics. Factoring was kind of seemed like it was more important. Quadratic formula is a way to always solve a quadratic, but it's very intensive in the calculations. Like we could do a whole lesson on quadratic formula if you wanted, but Up to you. So
What factoring do I need to do?
so this is two numbers that multiply to -2 but add to -1. So like 1 and -2 or -1 and 2. Do either of
1
those
minus
add?
2?
Yes. So that becomes x plus 1, x minus 2. And you pair that with the x plus 2 that was up here.
Hmm.
Sorry, I'm trying to get this thing to, let me
Do
show
you
you
have
that.
to factor at the end of the long division too?
Yes, but most of the time they're nicely factored like this. They're, quadratic of some sort.
So then what's the final answer? Is it that?
This right here, yeah.
Why would you, but how do you do the x plus 2? What do you do that?
Because that's the original one that you tried. That comes back down. So
So
whichever one you're
then
go ahead.
what would the long division answers actually look like then? Would I always do the same sort of factoring for all of them? How do I know which type of factoring to do and when?
These are all good questions. Most of the time in your typical like college algebra course, they will say you will use long division, you will use synthetic division. And they predetermine it for you. In terms of like what you're asking me here, it's like when we did this right here, you can factor x squared minus x minus 12. It's the same type of factoring. Two numbers that multiply to -12 but add to -1.
And is that always the type of factoring you do for division?
Not always. They could be unfactorable. They could be quadratic formula. I'm trying to find nice ones that are all factorable, so you don't have to worry about that.
How do I know the difference of which one to do? And which ones are going to be on the GED?
So I would recommend getting some of those tests so that we know the types of problems you're going to have. Like, I don't think you're going to get a problem that says to use synthetic division or long division because they're very like specific ways of solving problems. The GED is typically more of like factoring, not to the extent of this. Like this is a GED problem, like x squared minus x minus 12, solve that, set that equal to 0, solve that. Probably aren't going to get a problem that says like use synthetic division for this, but not sure. I'd be happy to get some tests, but I think they're all online now. I don't know if you've got a way to get a couple. We can certainly work through problems together if you'd like.
I looked at that Pearson VUE one and I couldn't find like any sort of free or like maybe I can open. I don't know if I'd be able to take it, but I could just open and screenshot my
Yeah,
GED practice test, and that way, even if I fail it, I'll have the screenshot
that would be good.
questions.
Yeah, what I saw is you had to pay, a couple dollars per test, $2 or $3 for a test.
Yeah, but then like when you open it, isn't it also timed
Yes,
too, like the
yes.
regular? So you can if you aren't prepared for it, then
Yeah, it's
you
it's
just
more about
waste it. So yeah,
getting the screenshots, like you said, would be really smart. That's what we're paying for, is to know what's on there, and then I can give you problems like those, to work on.
because I looked at the Pearson VUE and it seemed to be like it looked like it was stuff for like scheduling the GED test to do like online.
Yeah,
So
and they want
look
you to
into
do that.
that.
Yeah.
But
So what do you want to do? Do you want to do a little more synthetic division? Do you have another topic maybe we could, transition to here?
um, was there a next one
Like synthetic division problem?
or
Or
like
some,
a next topic?
I mean, there's so many ways we can go here. Like we're into like what we're doing right now is all about polynomials and curve sketching. It's like figuring out where these zeros are on graphs.
What does that have to do with polynomials?
That is a polynomial. Polynomial is this curve. The synthetic division tells you these points to be able to graph it. So like a question could be written such that it's like, here's the polynomial. Is this the correct graph of it? And you'd have
I
to
don't
find
know.
you'd have to find the zeros, which is what you just did, and go from there.
I never heard of that, and I didn't see that in the book.
Yeah, I'd be surprised if it was on there. Yeah, I mean, is there any materials you've got? Because like I just hate that we're maybe spending time on things that wouldn't naturally occur on the tests, you know.
Oh, is that the next thing to learn?
We're diving more into like the college algebra curriculum, which is these whole like, so the next thing is to write polynomials from the factors. So it'd be like write a polynomial with zeros at x equals 2, 3, and -1. That would be the next type of problem you would see. It's related to the factoring that we've done, but it's multiplying binomials. So we can look at that. I was just trying to see if I can find any tests here on the internet here. I'm sure you've looked.
Yeah, I mostly just find the like little mini practice tests that have usually the same questions on them.
Yep. Yeah, they all want you to have that, you know, they want you to pay that little bit to get something there.
Yeah, I'll screenshot all those the GED practice test questions and see what's on there. Because I'm trying to think about what they had in the GED book because I know they had like integers, whatever those
Yeah,
are
yeah.
called, and like slope of the line and all that stuff. But I don't know because I stopped at dividing polynomials in the GED book, but I forgot what the next lessons were. A lot of it was about like finding zero, like what is zero sort of
Yeah,
stuff.
I have a Course Hero account for some of my customers here. I've got, let me see if I can quickly find one here. Okay, here's a GED math test 3. I don't know. Let me, yeah, I mean here, let me grab one of these. It just logs me in. Okay. Like here is, you know, this is from Course Hero. Don't know how reliable it is, but they claim it's a GED test question. Does this look like something you have seen before?
Mm.
This is more geometry stuff, I guess.
Yeah, I think geometry is was like the very last section in the GED book. I hadn't gotten to geometry yet.
Okay. Let me find some other ones here that are a little bit more maybe straightforward for you to think about here. All right, so it says the sum of 3 consecutive even integers, that's very important, even integers, is 90. What is the greatest number in the series? Okay, sum of 3 consecutive even integers is 90. What is the greatest number? So any idea to start this or how you might?
So it's like what three numbers would add up to 90 and what would the biggest one of those three be out of all
Exactly,
those numbers?
exactly. Yep.
Mm,
But they're consecutive even, so it can't be the same.
I don't know. How would you solve it?
So one way is to use the answers. Like let's just say you were drawn to 26 as the answer. If that's the greatest number, then 24 and 22 would be the other two even numbers. See how these are consecutive evens? They skip the odd.
Mm-hmm.
But does the sum add up to 90? 22 plus 24 plus 26. So 24 plus 26 is 50, plus the 22 is 72. So we're way too low. So you could maybe try B, but that would be kind of slow, right? Like to do this each time. Do you agree with that?
Yeah.
So there could be a better way, but like let's just say you're like, all right, I think it's E. 34, 32, and 30. It's like, well, what does this add up to? These two add up to 66. This is 30. That's 96. So that's too big, but it's a lot closer than 72, right?
Yeah. So
So,
maybe if you do like the lowest and the highest one, you can kind of, I don't know.
so there's a test taking strategy in there to do that. And that's one of the ways that I would teach you to work on this test is, we can sometimes use the answers to do that. So let's say it's 32, 30, and 28. What do these add up to? Well, this ends up adding up to 90.
There's a lot. If you had started with the bottom one, it would have been like, okay, two more would be.
Yeah.
So do the, if there's a question like that, is it best to like do like the highest and lowest numbers and kind of.
So that's if you'd like to try the answers. If you'd like to try the answers, usually you try B and D because hopefully you learn something about them and you can squeeze the answer. Like say B was too small, but D was too large, you would know the answer is C.
Oh, okay.
And if B was too big and C was just, not, it was bigger, but a little bit better, then the answer is E. So there's a few ways that you can use the answers in certain problems to do that.
Okay.
And notice this is not, these are more what I consider numerical problems. They're not really formulaic. Are they all like that? I really don't know. I mean, they've changed the test and the books cover, like you said, they cover polynomials, they cover multiplication, foiling, factoring, all this stuff. But like, what I see is that they're more like numerical calculations, things like that. All right. So can we look at this question now together, maybe?
Yeah.
All right, awesome. So the next problem here says at the end of baseball season, 5% of the children enrolled in a local youth baseball program will be chosen to play in the state tournament. If 12 children will be chosen to play in the tournament, how many children are enrolled in the program?
So is this one where you have to find the base and the rate sort of thing?
Yeah, a little bit, yeah. Like if we knew the total, we could multiply it by 5% to get 12. But we don't know the total, do we?
So
But it's
it would
but
be, the part and the rate.
that's right. You know the part over the whole to get the rate. I guess that's the way they're teaching it.
Wait, so what am I trying to find then? Because isn't 5% the rate?
You're trying to find the total number of people.
So you would be, it would be like the 12 times the 5%,
You've got the 12 over the unknown.
or divided by the 5%.
Yes. Now that's pretty hard for most people. 12 divided by 0.05, what is that? You could, like I first made up here, this equation, the total times 5%. You could try each of these totals times 5% to get 12. Or like you just said here, this is the answer. It's just, is it here?
I don't remember how to divide decimals.
Yeah. So here's how, give you some hints here. You multiply the top and bottom by 100. The reason it's 100 is that moves the decimal place 2 times.
Okay, so it would be like
1200 over 5.
okay.
And then you can divide this maybe. I don't know, maybe that's not any better, right? It's like what, what's the best way to do it?
Is this the part of the test where I'd be able to use a calculator?
It's not, I would say no.
Because from what I heard, they only don't have you use a calculator for the first maybe like 10, 15 questions that are basic like arithmetic, and then everything else. But I don't know though. I don't know if they changed it.
Yeah, I mean, maybe check out some Reddit threads or something, or talk to someone that's giving the test. I just don't know the answer. The way to do this that maybe is faster is to look at 1200 divided by 10, which is 120. Okay, but because we cut this number in half, we have to make a change to this number, which means you end up having to double it. So it ends up being 240. We could look at another question, if that's okay.
Yeah.
All right. All right, so here's one here. I'll give this to you without the multiple choice because that probably doesn't help in this one anyway. So there's a missing parentheses here. I'm going to assume it's right there for the time being. Although that might not be true, but okay. This is a problem where you have to put the numbers into the equation. So it'd be like parentheses -2 squared, 4 times 8 for x, minus a -2 for y, like that. Does this look like something you feel comfortable reducing?
I'm confused why there's two parentheses.
So I like to use parentheses whenever I substitute. And the reason is it eliminates errors with order of operations. So when you put the number in parentheses, like I'm really treating it like there's parentheses there around the y, parentheses there around the x, parentheses there around the y. And that way you contain the signs properly. Like over here, the -2 squared, this is 4. But if you didn't write, if you just wrote -2 squared, well, that's -4, which is wrong. Because it's saying to square -2, not square 2 and then negate it.
How do you reduce?
So order of operations, you do what's inside parentheses first, exponents, then multiplication, division, addition, subtraction. So like inside parentheses here, you would want to multiply first, 4 times 8. And then this double negative here becomes a positive. And so you would then add and then multiply.
Okay, I forgot which one reducing was.
So 32 plus 2 is 34. Then you multiply by 4. So that's 100 and whatever, 36. Okay, let's try some story problems. Maybe we'll have some more success looking at some of those. I can see now why maybe you're that class you were going to, they'd emphasize fractions and decimals so much, because just to kind of cursory look through this, it's like, wow, there's a lot of fraction stuff going on here. But we can quickly get you back to being comfortable with all that again. All right, so it says on a road map, 1/4 of an inch represents 8 miles of actual road distance. The towns of Alton and Waverly are represented by points 2, 1/8 inches apart on the map. So I take that because it's probably not formatted well. It's 2 and 1/8 inches apart. What is the actual distance in miles between Alton and Waverly? Any idea how to proceed here?
Um, so it'd be I'm not sure.
So 1/4 of an inch is 8 miles. That's really important here. We're going 2 and 1/8 inches. So maybe start with the easier one. You can always kind of break the problem down into smaller. It's like, all right, well, if you go 2 inches, how many miles is that? So my question to you is, or thought is, how do you go from 1/4 to 2? Like, think of how many quarters are in $2.
8.
So if you multiply by 8, you get to 2. So you multiply this number by 8. So that's 64 miles. Do you agree with that? Kind of see how that works? You multiply one, multiply the other.
Yeah.
So what's this is a testing strategy now. Is do you see how A, B, C, and D are all too small?
Mm.
So the answer is E. We don't even have to keep going because E is the only one that's even reasonable. Now, how does it actually work? Well, 1/8 inches, 1/8 inches is really half. It's half of 1/4. Okay, so to go from 1/4 to 1/8, you're basically multiplying by a half. So you take that 8 miles and you multiply it by a half, which is 4 miles. So those two added together, 64 miles plus 4 miles is 68 miles.
Okay.
All right, here's maybe another order of operations problem. And these are easy for me to make up ones like it. Like if you're like, hey, Matthew, I really want a bunch more like this last one, you can absolutely do that. That's not too bad to make up on the fly here. Okay, evaluate 6 times 10 to the 5th in parentheses divided by 4 times 10 cubed. This problem is likely not a calculator problem because everyone would just use their calculator. Although it might be because the order of operations is so important here to getting the right answer. We've not done much with scientific notation. But maybe you can still do something like this. Do you remember how to rewrite numbers 6 times 10 to the 5th? As a number with zeros, 6 times 10 to the 5th.
I don't know.
So it's a 6, and this 5 tells you how many zeros follow. 1, 2, 3, 4, 5. Oh, almost couldn't count. And then 4 times 10 to the 3rd is a 4 followed by 3 zeros. And we're dividing. When you're dividing, the zeros always cancel like that. And you're left with 600 divided by 4. Do any of these answers stand out to you for that?
Mm-mm.
Okay, so we can do a simpler problem here. Like, what is 60 divided by 4? Does that all help?
I don't know. Maybe C.
It is C. Yeah. So sometimes you can just sort of say, okay, I think I know it. You can
I just
divide.
guessed.
Oh, okay, well, we don't want to guess. You can divide both of these numbers by 2. I think we did this one of our very first lessons here. Like that's 300 and that's 2. And then you try dividing them again by 2. 150 and then 1. So it is in fact C. Okay, let's try another one here. All right, a house and a lot cost $120,000. Okay, so they're saying the house here and then the land that it goes on together is $120,000. If the house cost 3 times as much as the land, how much did the house cost? So we're trying to find this one. And we know that whatever this is, it's 3 times as much as the lot. Any thoughts here on this? How do I maybe proceed?
Oh, I'm don't know because I misread it. I thought the lot cost 120,000.
Yeah, easy to do. I actually did that myself here because I just looked at the lot cost 120,000, but it's the house and the lot cost 120,000. So sometimes you just, like we did before, you just pick a number like B. Okay, so if the house cost 40,000 and the house is 3 times as much as the lot, is the lot more or less than 40,000?
Less.
Less. And we'd have to divide this by 3, but this number actually does not divide by 3 very well. So we probably shouldn't try that number. Let's try C. Let's try 60,000. Does 60,000 divide by 3?
Probably because there's a 6 in it.
Yes, it does. 6 divided by 3 is 2, so this is 20,000. What do these add up to?
80,000.
Which is too low. So we know it can't be A, it can't be B, and we know that C is wrong. So I don't want you to guess, but if you did have to guess, it's better to guess between 2 answers than
Then it would just be D because C is the final answer.
That's right. The lot is a third of this. They add together to make that right there.
And that's one where you would kind of just have to go through the answers.
Going through the answers is a good strategy. Yeah, there's like this is another one where using the answers can help. Now it's slow, really slow, but like if you had infinite time, you would do this. But hopefully, when you see some of these, you will start realizing, oh, I'm going to use the answers, or I'm not, or I'm going to try this out. This problem says 2 adults and 4 children pay $48 to get into the fair. So I look at that and I say, okay, 2A plus 4C equals 48. A child's ticket is $6. So we know that that's C. 2 adults plus 4 times 6 equals 48. 4 times 6 is 24. What is the cost of an adult's ticket? So there's some number in here that when you multiply it by 2 and add it to 24, you get to 48. Now you could solve, you could try answers. Maybe you see one that works. What do you think there?
The child's ticket is $6 less than an adult's ticket, though.
That's true. So I made a classic mistake here. Man, they really do make those tough. So can't do this. What you can do here, though, is if this is the adult ticket, like let's say 18 is the adult ticket, the child's ticket is 12. because it's $6 less. And then you can try 2 times 18 plus 4 times 12, which is too big. So maybe we try C. Okay. That means that the child's ticket is 6. 2 times 12 plus 4 times 6. Is that 48?
No.
2 times 12 is 24. 4 times 6 is 24. Those add together to get 48. Good catch on that. It still worked actually, which is really surprising, but for the wrong reason, which is not good. All right, so maybe you don't need to get any tests. I've got